Welcome to day 22 of our journey through the standard template library. Today marks a turning point as we transition from learning STL containers to harnessing their full potential using STL algorithms. We will begin by exploring three fundamental yet powerful algorithms: sort, find, and count. These are not just utilities, they are high performance, industry grade operations that replace repetitive manual logic with elegant, optimized one liners. By the end of this session, you will be able to use them confidently across real world scenarios. Let's begin by understanding what algorithm is. It's a C++ standard header file that provides over 60 functions that work on containers using iterators. Think of it as a toolbox filled with essential utilities: sorting data, finding elements, counting frequency, removing duplicates, transforming sequences, and much more. These algorithms don't belong to the containers themselves. Instead, they operate on them, using iterators as access points. This design enables high reusability and separation of concerns. You will use containers to store and algorithms to operate. Why should we use STL algorithms instead of writing loops ourselves? The answer lies in performance, readability, and abstraction. STL algorithms are extremely well optimized, often better than what we might hand code. They make code concise and expressive. Instead of writing a 5-line loop to sort or search, a single function call does that job. They also encourage consistency, reduce room for errors, and integrate beautifully with lambda functions and custom comparators. In short, they let you focus on what you want to do, not how to do it. Our first algorithm today is sort. It's one of the most commonly used algorithms in C++. The syntax is simple: std : sort start, end. This sorts the elements in ascending order using a less than operator by default. If you want custom sorting, you can pass a comparator function or a lambda. Note that sort works only with random access iterators, so vectors, arrays, and dequees are okay. But sets, maps, and lists won't work because their iterators don't support random access. Keep that in mind when choosing your containers. Let's bring sort to life with an example. Suppose we have a vector of integers 5, 3, 9, and 1. A call to std : sort v.begin, v.end will sort it in ascending order, giving us 1, 3, 5, and 9. If we want descending order, we can pass a comparator greater. This flips the sorting criteria to use greater than symbol. Notice how elegant and readable this is. No nested loops or manual swap. It's production grade sorting with just one line of code. Next up, find. Searching is a basic but critical operation, and std : find makes it effortless. The function takes a range defined by iterators and a value to look for. It returns an iterator pointing to the first occurrence of the value, or the end iterator if the value isn't found. It works with all containers that provide iterator access: vectors, lists, dequees, strings, you name it. This is perfect for quick membership checks and location-based logic. Let's look at a practical example. Consider a vector of integers, say 1, 2, 3, and 4. We want to know if the number 3 exists in it. We call std : find v.begin, v.end, 3 and store the result. If the iterator is not equal to v.end, that means the value was found. You can even calculate its index by subtracting v.begin from the iterator. This is a very efficient and clear way to search through containers without writing error-prone loops. Third algorithm for today is count. It helps us find how many times a certain value appears in a container. Like the others, it takes a range and a target value. It returns an integer, the number of times that value occurs. This is incredibly useful in data analysis, frequency tracking, and validation logic. Whether you are counting votes, characters in a string, or repeated inputs, count is your friend. Here's a clear use case. Imagine a vector with the elements 1, 2, 2, 3, and 2. You want to know how many times 2 appears. std : count v.begin, v.end, 2 gives you the answer, which is 3. That's it. No loops, no counters, no conditionals. one line, that's the elegance STL algorithms bring to the table. Before we wrap up, let's talk about common mistakes. First, never forget to include algorithm, otherwise these functions won't compile. Next, avoid trying to sort containers like std::set or std::map. They are already sorted internally and don't support random access iterators. Also make sure the iterator range you provide is valid. For example, don't reverse begin and end. Finally, understand the difference between begin and cbegin, especially when working with const containers. It's time to get your hands dirty. Try these practice tasks. First, sort a vector of strings alphabetically. Second, count the number of times the character A appears in a string. Third, use find to locate an element in a DQ. And lastly, sort a vector of pairs based on the second element using a custom comparator. These tasks are great for solidifying your understanding and getting comfortable with syntax and iterators. Let's see how much you have absorbed. Quick quiz. What does std::find return if the value isn't found? Can sort be applied to sets? How do you sort a vector in descending order? And what's the time complexity of sort? These questions not only reinforce your learning but also prepare you for interviews and coding competitions. To summarize, today you have taken your first steps into the world of STL algorithms. You learned how sort helps you order elements efficiently, how find lets you search with clarity, and how count simplifies frequency tracking. These three are just the beginning. The STL algorithm suite is fast and powerful. In the coming days, we will build on this foundation and unlock even more powerful tools like binary search, partition, accumulate, and next permutation. See you in the next session.